we want to see lead times get back. And it's not healthy to be as long as they are. We don't like to see it be either, right? But we're in this, a generational change. And so we're trying to find out what the new normal over the next 3 decades is going to be. But it's not sustainable that we have 4 to 5 year lead times on infrastructure equipment for a really long extended period of time. So that's why we're increasing capacity.
Welcome to the Energy Solutions Podcast. I'm Todd Snitchler, President and CEO of the Electric Power Supply Association. That was Matt Neal, President of North America for Siemens Energy. That reality, multi-year lead times for critical equipment like natural gas turbines, is one of the most important factors shaping the future of power generation in the United States. Electricity demand is rising rapidly, driven in large part by data centers and new industrial load. And while all resources are critical to the system, that demand is increasingly being met by natural gas generation because of its ability to provide reliable, dispatchable power at scale. In fact, Wood Mackenzie projects turbine orders will peak in 2026 as developers move to secure equipment for more than 60 gigawatts of new gas capacity expected to come online between 2026 and 2030. While competitive power generators have the private capital and decades of experience to build quickly and cost-effectively, they're facing the same supply chain constraints and workforce shortages as the rest of the industry, including vertically integrated utilities. For all developers, access to gas turbines and other critical infrastructure is now a central factor in how quickly new generation can come online. That said, EPSA members have already taken concrete actions to secure turbine capacity and workers to support construction of new generation. And manufacturers like Siemens Energy are responding with new investments and innovations aimed at expanding capacity, improving efficiency, and easing these bottlenecks. In this episode, we get the latest from Matt Neal on what's behind extended lead times, how Siemens Energy is scaling manufacturing to meet demand, and what it means for the entire power sector working to keep up with unprecedented load growth. Here's our conversation. Well, Matt, thanks very much for joining us today on Energy Solutions. We're delighted to have someone here who can talk to us about one of the topics du jour, which is turbines and how we're going to meet the moment and all the issues that are facing the electrical grid at the moment. And Siemens Energy, of course, is front and center with a lot of that. So for much of the last decade, we've been talking in the power sector around flat demand, load growth that was pretty static and not much of anything. And then very recently, we're talking about major load growth, and that's from AI, data centers, electrification, increased manufacturing. And from Siemens Energy's vantage point, how significant is the moment for the power sector and for your organization specifically?
Yeah, I think the way I've heard it best described is it's a generational shift, right? It's a generational shift in that we're moving towards growth and the addition of gigawatts of new energy and the infrastructure to move it around to where it needs to be. And I was in transmission for about 10 years before I stepped into my new role.
Okay.
And, we kind of saw it happening in transmission. We like to say transmission was 2 or 3 years ahead of what has now been really felt in the generation space as well.
Sure.
But like you said, there was just decades of very low CAGR, very low growth. And we were always kind of creeping up to that ceiling of, hey, we see that but I think we just had gone so long without seeing that growth that maybe folks didn't believe it. And then it really hit us. And It's now, hitting generation as much or more than it did a few years ago in transmission.
So everybody's got their favorite projection, I think. And we see a new one every week about what load growth is going to look like and how fast and where and all that. Mm-hmm. As you all think about it from the equipment manufacturing side of things, how much of this do you think is specifically tied to AI or hyperscale data centers, or maybe more broadly? Yes, that's part of it, but you're thinking about it with a more global perspective. I think it's helpful to get an outsider's view who's maybe a supplier to the industry as opposed to the folks that are the quote unquote experts who have lots of views. I'm just not sure which one's right. So I'm interested in your perspective.
Yeah. So if we think about it globally, data centers are really it's really a U.S. topic. Mm-hmm. When it comes to the extreme growth, right? I mean, if you look at cloud-based infrastructure, that's going in and around the world, and that's driving, moderate growth in pockets. But really, the demand for energy as a result of training AI is really a U.S. topic. I mean, obviously it's a China topic, but There's a lot of geopolitics in that statement, right? So,
That's right.
that's very U.S. focused. And if I look at our business today in the U.S., it's a hard question to answer because, the utilities are fielding a lot of the demand in kind of their everyday business. And then now there's behind the meter and kind of more targeted customers. But if we look, our estimation is around even 25% of our demand in Q1 of 2026 was directly related to data center customers. So it's not the majority, right? But again, you'd have to spend a lot of time dissecting the long-term planning from utilities to determine how much of each individual utility load growth is coming from data centers.
So as you look at that, does Siemens Energy have an estimate for load growth? I mean, obviously you're planning to build into some future outcome. Have you guys kind of put pen to paper on that, or are you doing what most of the industry is doing, which is relying on all the other reports that we see coming from pick your favorite 3 or 4 letter agency or organization that's put one together? I don't know if you've done one internally or if you rely on others like we end up doing.
We do our own internally, and it's actually what we would say, like our own bottoms up is actually higher than what you see even in the market, because we're seeing a lot of requests that aren't even at the point of going into a queue, right? I mean, it's a development before the queue request has even been submitted. But it's everybody takes a haircut, right? And trying to determine how much of all these requests can really go forward. And I think our overall industry feedback is we know that not everything requested is going to go forward. And we are kind of realistically building our capacity to meet demand as much as possible. I'm not saying that the long-term demand forecasts don't matter. They definitely are indicators that we're constantly paying attention to. But we're always balancing that with how much can we realistically, from a workforce and supply chain standpoint, build our capacity.
Yeah, we're thinking about it in a very similar way, which is load forecasting is critically important. And as David Hill, who has been on our podcast before from the Bipartisan Policy Center, said, you'll be wrong and you want to get it as close as you can and a little bit on the upside, not on the downside, to make sure that reliability is managed and all that. So I think we're all kind of in the soup together on that. I'll just jump right to the $64,000 question that everybody talks about, which is, what's the lead time on turbines today? I mean, everyone's heard the story. Everyone's kind of got a sense for where it is. But of course, you're the one that's actually working on developing and constructing this equipment. Is it really 5 to 7 years? If it's not accurate, what's a better look for people to kind of get their heads wrapped around? And what's driving the constraint? Like, why does it take so long?
Yeah, I would just say in general, right now, it's really difficult to get a turbine before 2030. If you look out in 31, 32, there's more flexibility to support demand. I think that's where that kind of 6 to 7 year number comes from. It's not quite, it's not 7 years. It's a little less than that, but I would just say, not much before 2030 is still available in the market, if any.
Well, and you mentioned a minute ago that people are maybe changing how they're procuring their turbines before there's a queue spot. Are you seeing a change in customer behavior, or is that something that's kind of always been the case for those that aren't developers and are kind of listening to this conversation saying, is that new, or is that the way people have always done it? Can you shed a little light on that?
Yeah, really everybody has changed to going towards a reservation model as opposed to, a normal RFP and bid process, right? And that's really across the board. That's the biggest commercial change. It's just people having to get their supply chain, further up in their development cycle and their build cycle, and then look to kind of put on the rest of the pieces after you got your major equipment ordered. That's even true for transformers, right? We're a large power transformer. It's the same story.
Yeah, I guess we're behind the days of just in time when it comes to at least this sector of doing construction.
I think, look, we are very admittedly put out there that we want to see lead times get back. And it's not healthy to be as long as they are. We don't like to see it be either, right? But we're in this, a generational change. And so we're trying to find out what the new normal over the next 3 decades is going to be. But it's not sustainable that we have 4 to 5 year lead times on infrastructure equipment for a really long extended period of time. So that's why we're increasing capacity.
And thank you for that. You're kind of leading me right into my next question, which I certainly appreciate. So there's some big news that Siemens Energy's made a recent announcement about, which was $1 billion investment to expand your U.S. manufacturing footprint. How do you think that investment plays out to address the surge in demand, to increase your production capacity, both maybe speed and volume? So kind of talk to us a little bit about what this investment's going to do for you, but also for the market more broadly.
Yeah, so let me break it into the two big chunks, which are our gas generation and our grid business. So
Great.
most of the investment, like 60 to 70% of the investment, is on the grid side.
Okay.
And these are investments that have been made in the last probably 24 months, right? So we got to a point where we thought it was really important to communicate kind of the scale of what we were going to invest. And again, we look at it, we're building a new switchgear plant in Mississippi, and we're building a new large power transformer factory in Charlotte, right? So we can build substations faster. Those were our most critical need. On the gas generation side, we have a facility in Charlotte that we do. So we've been doing service work for, a decade plus, 10 to 15 years, right? Since we built that facility. And we have brought new unit manufacturing for advanced class gas turbines to Charlotte again. And that's going to increase our gigawatt output. We're forecasting in 2030 to be kind of in that 40 gigawatt a year, increasing it from we were in the mid 20s last year. So there's quite a bit of increase as a company. But think about it, most of that increase is coming from optimization of the global network for gas turbines. Charlotte's a part of that, right? It's important that we bring it back to the US. We're still going to do service work there. But yeah, bringing new unit back to Charlotte was a big deal. And then I would also mention something that gets forgotten a lot, like a gas turbine is worthless without a generator.
Kind of an important two-parter there.
So we make generators in Charlotte as well, and we're investing in that capacity. They have a feeder plant in Alabama that provides the stator and rotor windings and components. Right. So that feeds Charlotte. So that was also a very important part for the gas generation business to increase our generator output.
Yeah, I think that's great news broadly. And I'm glad that you mentioned the substation issues, because we don't deal in that world a ton. But I did have someone come share with me that people sometimes overlook that supply chain is also caught in a relatively long time horizon. And that can't be overlooked when you're trying to build out a system. It's not just one piece or another. The whole thing's got to work together. So it's great to hear that you're working on both sides of the equation. So as you think about those investments, how do you think that affects the current timeline projections? Do you think by 2030, we're back to a spot where you're on kind of whatever normal would look like, or is that a TBD?
So 2030 is a very critical time in the energy industry, I would say, right? I mean, by that time, we will have a more clear picture of what's the outcome of all these AI training centers that are built. I think there's still a lot of question marks in the technology from the GPU manufacturers on efficiency. Is the next model that's going to come after this first wave, is it just even more energy hungry? Which some folks say that, right? So it's a hard question to answer because we've never done this before as a society, as far as build these models and then try to commercialize them as a society and digest what they're able to do, for everyone. Right. And so we're really just spending a lot of time with the hyperscalers and with other technology folks in and around that space and energy, thought leaders on trying to figure out where we go again, 2030 and beyond. I think Fareem was at CERAWeek and made a comment in his panel about, that's critical because we're really struggling with data kind of transparency beyond 2030.
Yeah, that seems to be everyone's struggle. We think we can kind of see, but nobody can see quite around the corner yet. And everybody's trying to poke their head around. We just can't quite get there.
And I think it's the slope of the growth curve after 2030 is what we're trying to figure out.
Yeah. And it depends on the region, right? I mean, you've seen PJM adjust down their shorter term projection, and then they raised their longer term projection out 2030 and beyond. So that's just one example of an area that's had to deal with some of that. So you mentioned hyperscalers and your interaction with them and data centers being a driver in the power sector investment. How are those customers changing the way generation projects get structured? Have you got a good line of sight? Because these are not your traditional projects, right? They're larger loads. They're coming on quickly. They want to move as fast as humanly possible. And then it's the question of interconnection, and then it's the supply and all the other things that kind of are downstream from that. How are you seeing that impact both what you do and how projects are developing over time?
I would say there's two main aspects of it. The first one is just we've never built gigawatt scale
Yeah,
campuses
that's fair.
of anything ever, right? I mean, there's like maybe 1 or 2 gigawatt scale assets in the world.
Yeah,
There's some stats out there about there only being a handful of 500 megawatt, petrochem, large power consumers.
right.
So first of all, we've just never built these campuses at gigawatt scale. And so that comes with it execution. I mean, you've got a lot of different technology providers in a really
Sure.
small space trying to execute simultaneously.
Yeah.
That requires more coordination. So we're very much trying to prepare for that with our teams. We're putting large gas turbines and medium gas turbines in the same facilities. So we're working on that. And then the transmission to interconnect it all. And then the second piece that is really important to mention is the benefits to the system that will come once these assets are available. I mean, everything's going to try to get grid connected in time.
Yeah.
It's kind of the feeling that there's value in those assets long-term being part of the energy system. But because we've never built gigawatt scale campuses, we've also never interconnected them. And speaking more from a transmission background,
Sure.
right? So there's a lot of efficiency from large power flow optimization, moving power places. So I think those are going to be the secondary realities that can also be very beneficial if done. I think you said earlier, reliably, right?
Yeah.
And that if we can increase reliability from having these assets available on the system, then that's also a story that we as an industry need to make sure that we tell so that folks don't see these just as adding to the cost of building out infrastructure.
Yeah, that's exactly right. Sometimes I think people lose sight of the benefit that they're already getting from it and that there's a cost associated with it. Of course, we want to mitigate those costs best we can, but I think sometimes we have to have the whole conversation, not just the parts that people want to talk about. So
Yep.
As you look at these, are you seeing the interest in co-location to move quickly now? As you know, it seems like everyone's going to want to get interconnected at some point in the future, but is that changing the approach, or are you seeing a different set of customers because people maybe who weren't traditional buyers who say, look, I'm going to co-locate and I want you to help us do this faster? Is that something you're experiencing, or is that just
Yeah,
something we hear
definitely.
about but isn't happening?
No, it's definitely happening. And you've got a lot of the power developers of the merchant style power developers of the last couple of years, right? Moving into, bringing their expertise of developing power and bringing it to the hyperscalers so that they can move faster. I mean, so it's definitely a reality. And look, I think that's also a good thing that we had companies out there that had experience on developing power and partnering up with folks to make it happen. Hyperscalers don't have that in-house expertise. And so I think there's value in what's kind of developed in this market of bringing this co-location and behind the meter applications into, directly with the hyperscalers.
And our members are happy to bring that expertise to them in an effort to try and help solve that problem. So we talked a lot about some of the technology, but gas turbines, of course, seem to be the technology that's going to play a central role in meeting the immediate and probably medium and longer term reliability needs. Can you talk about, from your perspective, why these are well designed or well suited to meet kind of where we are today and what we see going forward? I think we generally have a sense for that, but you're more on the technical side. And I think it'd be useful for folks to hear from your perspective why this technology just seems to fit.
Well, I think, first of all, from a supply side standpoint, the U.S. is very fortunate to have the natural gas supply that we do domestically and the security in that supply. So that's really, I think super important, and it's become more important for obvious reasons that we have developed that infrastructure to go and find it and then to be able to transport it to where it's needed. So that's a big deal. But then when you look at the technology itself, it's a mature technology, right? And I think that's the other reason why it's so important that we can, do so much of it here in the U.S. is that it's matured. So now we have pushed the limits of efficiency because ultimately we're trying to lower the cost of the ultimate product as much as possible. And when you're using gas turbines for more baseload applications, to be able to, increase efficiency and the size of single units, really to kind of push the boundaries of the technology. We've done that over the last 10 years or so. We've really focused in on bigger machines, more efficiency, higher outputs. And now we in this boom, we have seen a more of a focus on how fast you can get the megawatts out and how reliable those megawatts can be. So not as much focus and interest on pushing the limits of efficiency.
Sure.
So that's been, thank goodness. If we would have had to make nothing but our most efficient units over the last, it would be really difficult, right? So we've been able to kind of fall back on a lot of our designs that are kind of our workhorse type products.
Sure.
And so we're really, getting a lot of those out the door because look, there's not going to be a whole lot of step changes in gas turbines, right? When you just look at the heat and the output and the materials that allow that to happen,
right?
You're kind of at some of the,
we are where we are.
Yeah. So kind of evolutionary changes we could expect, reducing emissions, those type of things will be focused on, but just getting that output with, less input we're kind of at the limits there a bit.
So for those of us that don't build this kind of equipment, and for people who have never seen it, until you actually see one, I don't think you can appreciate just what goes into constructing this stuff. What's the hardest technical challenge in designing and building the turbines today? You mentioned the really high efficiency ones, but able to come back to the workhorse because, speed is important, but also performance is important. What are the things that, as I like to say, Bob and Betty Buckeye, if you're from Ohio, what do they need to think about as you talk about, like, look, we're getting from here to there. What are some of the technical parts and challenges that you have to go through in order to get one of these from the factory floor out into the field?
Yeah, from a supply chain and just manufacturing and then operation standpoint, we talk a lot about blades and vanes. These are the components internal to the combustion cycle that see the most heat and have the most wear during operation. Sure. And as we've made bigger and bigger, higher efficient units, we've had to introduce newer ways of, they're bigger in size than they were before.
Sure.
So these are castings of, they're very unique style castings that are then coated with rare earth materials to withstand the heat. And they have all these cooling design and, really small kind of microscopic holes for cooling paths and things, right? So that you don't exceed really the physical limits of the materials. Sure. So that's both a challenge in new units as far as getting the yield up and producing those parts, right?
Okay.
It's not this, it looks like a traditional kind of casting environment where you cast metal, but the tolerances are so high. You have to be so precise that it makes sometimes the yield is not as high as you would get out of normal casting, right? Okay. So that's tough for us. And then obviously when you burn something that's, at those temperatures and those stresses, you have to replace them frequently.
Sure.
And so it's this constant plan of how much do we need for a new unit? How much do we need to support the fleet? Because we have to during a routine maintenance cycle, we have to go and essentially, it's like rebuilding your car engine. You got to take the whole thing apart, go find all the seals and gaskets and things that wore out, and then put it all back together. And so that's the real thing that folks don't. I came from transmission, right? And I've learned this myself, right? But just the appreciation of being able to keep the fleet operating. And even in this crazy growth, that was one of the first things we did was focus on what do we do to make sure that every machine that's out there is operating. How do we get immediate efficiency out of the existing fleet? So we pushed all those measures to the maximum while we're trying to get the supply chain and workforce for a new unit behind it.
And I think that's an important thing that sometimes is overlooked is there are thousands of these machines out in the field and we need them to continue to work. Because if they don't, you can add all the new machines you want, but if you're losing megawatts out the back end, it's not going to help ensure reliability. So since we've talked about that a little bit, as we've seen the grid composition change a bit, more renewables have come on. Now we're dealing with demand growth. Reliability remains ever at the front of the line about the focus for what our members do, but how the system should operate. How do you think about how turbines and modern power plants can help support the grid as it becomes more dynamic, as we see evolution of the resource mix that's on the system and how it actually is dispatched and performs? How are the plants that you're helping to build and supply, how do they fit into making that work reliably and efficiently?
Yeah, look, this term of inertia on the system is important. And, having dispatchable resources that naturally bring inertia. And just for folks that might sound like a word that you don't
the non-engineer types, help us understand that.
Yeah, I view it like a water hose, right? It's not only how much water or how fast the water is moving, but it's, imagine that like you tried to take your garden hose and put your hand on it. Would you
Mhm.
be able to hold your hand on there or not?
Yeah,
Right. And to me, that's a lot. That's kind of what electrical inertia, again, in layman terms,
sure.
is just the force that's coming, and a lot of renewables are coming from weaker sources of generation that inherently don't come with as much electrical inertia. So
Yeah.
you got to be able to push power down the line, and you got to be able to, when things happen, the power can fluctuate in a weaker system more drastically, right? If you've got this really strong inertia behind it, then it quickly grabs
Mhm.
itself, corrects itself, and keeps going where it's supposed to go. And so naturally, gas turbines bring more inertia to the system. There are a lot of other technologies that allow you to maintain reliability and keep inertia up without rotating mass, but they cost money. And so there's a balance there. And
Yeah.
so there's a balance of having that dispatchable high inertia generation with, because if you didn't have to do all this other stuff for renewables, it would be by far the least expensive option, right? But it does
Sure.
come with inherently higher costs in other areas. So again, finding that balance is really important. Siemens Energy is super unique in our ability to do that. We have
Mhm.
technologies across the spectrum, and we spend a lot of time studying and talking with utilities and even now hyperscalers on making this an efficient system that is ultimately as low a cost as possible. So,
Yeah, I'm going to resist the urge to nerd out a little bit and talk about spinning mass and inverter-based resources and volt var and all that. And
yeah,
we'll move on and talk about things that maybe people would understand a little bit. So
that's
power
good. Okay.
plants today, when they're constructed, typically have 30 or 40, maybe even longer life cycles. When Siemens Energy engineers are designing a new plant today, what assumptions are they making about both how it will interact with the grid now and in the future? Part of it is we've talked a little bit about looking around the corner, but how are you thinking about how this equipment will last and be utilized over that longer time horizon while there's so much uncertainty that we've been talking about?
Yeah, it's a good question. I think right now we've been so focused on just meeting this demand of these kind of really large scale single points of need
Sure.
that I would say the optimization is still to come. I mean,
Okay.
we've also just gone through such a period of focus on renewables, and now we've really pivoted hard.
Hmm.
I would say again, the word in my mind is just there's gonna have to be a better balance as we go forward.
Yeah.
I would just say that's my thought. I think it's really healthy if we go through this build cycle to meet this unique demand, and then we could continue on this cycle. But also, I think we need to try to find balance in the system for long-term sustainability.
Yeah, this pendulum issue is a problem across the board from the supplier side, from the owner operator side, from grid planner side. I mean, it's an issue that we hopefully can wrestle to the ground at some point here. Do
Mhm.
you have thoughts about what an ideal power plant would look like in 2040? Let's say we get through the build cycle and we're thinking about where we're going to go. Does Siemens Energy have thoughts about that? Or is that so far out? Like, hey, look, we're trying to deal with now to 2030, but I'm sure you have people thinking about, future states to what the system will look like. I'm always curious how folks are thinking a little longer term because we try to do
Mhm.
both as well. And
Mhm.
for being a supplier to the industry, we assume that you're similarly situated. Do you have thoughts about what that might look like?
I mean, we definitely think that like nuclear is going to have an important place. I still think there's a strong debate on what SMRs really are and what the application really should look like. Have it be,
Yeah.
SMRs or, kind of 1,000 megawatt blocks I
Yeah.
think that's a healthy discussion but I think the momentum of going towards, more nuclear is good.
Hmm.
And then there's a lot. I mean, I'm a firm supporter and believer in just technology is going to continue to advance, and it's going to
Yeah.
advance for all sources of generation and transmission. There's
Yep.
going to continue to be a lot of investment in energy. I mean, if we're going to increase power by terawatts only in the US,
Yeah.
then there's naturally going to be more innovation and efficiency that's going to come out of that. I think there's fusion, there's a lot of different stuff that's going on. And I think by 2040, we will see a much more sophisticated mix on the
Yeah.
system is my view. And I mean, that's what we think about as a company is how does that evolution happen? And also, I think we think about it now in terms of addition, right? I think we all are getting in that, and security, addition and security, right? I think we're all kind of trending towards that realization that we need more energy. Society's going to need more energy. And so we need to do that with a lot of our sustainability goals in mind, but then also think about security while we're doing all that.
Yeah, there are no shortage of issues that are across the board that we're thinking about. So I'm going to bring one more to you and kind of talk about how you're thinking about workforce, because that's one of the issues, of course, that is an input to how you're going to get where you need to be. That's one of the things that we need when it comes to the age and experience of our operators and the utilities needed on the wire side. So, I mean, everybody's dealing with it, but it's not just an equipment supply chain issue, but there's a workforce question. Is this a constraint that you're dealing with, to have skilled engineers and technicians in manufacturing? We kind of hear a mixed bag about reporting about manufacturing, but you're in the heart of that and you deal with that every day. So is it the challenge that some are suggesting, or do you have this workforce that you need, or is it something that you're focused on expanding?
Yeah, we're super focused on expanding workforce. I personally am optimistic on workforce. I think that
great.
Optimistic in the sense that I always think people are more adaptable than maybe we give them credit for, right? And
Sure.
I think as our industry becomes something that everyone realizes is critical, and we need to make this equipment, and it's really sophisticated, highly engineered digital equipment now. So I'm optimistic that with our investments and what we're doing, even in, the high school technical trades, leading up into community college, leading up into 4-year degrees in engineering, I think bringing back that hands-on just reality that these are great jobs and great careers. And then you throw on the ability to become an expert in digital technology while you're doing it.
Yeah.
I'm just optimistic that that's going to play out well. And we just need to have the discipline to stay focused on it and not let some shiny object teach us as a society that we don't need to do this stuff again, right? And we met with some folks in kind of the high school education, technical trades, and most of those programs are abandoned around the country.
That's right.
Shop class, right? It's gone. And so we need to refocus on that and stay disciplined in it long term, but then not just have it be working on a lathe, but bringing in software, bringing in digital tools. So again, and I hope this isn't too far out there for this discussion, but there's a change in mindset in how we apply engineering and how we apply technical trades, to where if you utilize some of the new AI, again, the way that you can cycle data faster, right? You don't have to be a super big expert. Like, you don't have to be an expert with all these years of experience to know you can do a 50-step process and at the end, it's going to come out right? You can chunk things in and you can get feedback much faster in your development cycle. So you build in these little mini cycles as you evolve your design and you evolve your technology. And that allows people with less experience to have more output, right? Because you don't have to be an expert, because you're learning through your cycles. And I think that's going to be something that you've seen certain startup style companies take those paths because they don't have experience, right? They have a workforce that has no experience sometimes, so they have to learn through cycles. And I think that's going to be something that with AI that you're going to see in a lot more different applications and across the board in workforce. So
I think that's an interesting observation about what AI can actually do for workforce. I mean, I haven't heard anybody mention that before. We're always so focused on the LLMs and, all the other things and your Netflix and financial transactions, but you're actually talking about how some practical applications from AI can actually develop both workforce and a quicker turn on technology, which I think is what everybody's looking for. I think that's a fascinating take on that.
Yep.
So AI is kind of this global race. You mentioned the geopolitical struggles that, are involved in here, and demand surge isn't only happening in the US, and you're an international company, of course, but how does the global competition for turbines and equipment and all of the pieces and parts that go into the system affect the ability to build generation here in the United States, but also how are we thinking about things from a global perspective? Certainly from Siemens Energy's perspective, I guess.
Yeah, I mean, look, this is what I spend a lot of time on with leadership, with my counterparts around the world, and trying to understand the geopolitical impacts on our supply chains and in our own company infrastructure, and where we have critical facilities and what's going on in those regions. I will say that that's been a big challenge and something that, again, I think all companies now are spending more time on the security of even your own operations and making sure that not just something that is somebody else's problem.
Yeah.
And also with technology is kind of also allowing a more isolated view sometimes from government standpoint, right? Because you used to maybe have to go somewhere else in the world to get something. Now I think a lot of folks feel like they can develop everything in-house. But then the reality of companies like ours that are very, very global. I told somebody the other day, I almost feel like the companies are going to hold the world together. And so that's a challenge. And we're having to adapt to that reality as well, but also stand to our own values and our own beliefs and not be afraid to maybe stand up when we need to, because some of this stuff is very disruptive to what goes on. So,
100%. So appreciate the time, and I'll bring it to a close with one last question for you, Matt. So if the United States is going to meet this new wave of electricity demand while maintaining reliability and affordability, what do you think needs to happen across the industry? And you can take that from just the manufacturing side. You can do the entire electric system, having been on the transmission and the generation side. But from your perspective, what do you think we need to do in order to meet those twin objectives of reliability and affordability?
Yeah, I mean, I would say number one is I would focus on the reliability first. When you think about what delivering electricity to households, it's the greatest product ever made and sold on the planet.
Yeah.
Couple $100 a month and you get to electrify your house. You go a month without electricity in your home, you'd pay thousands.
Right.
So I would say number one, focus on reliability, and then the affordability part long term will come from, again, finding the proper balance in the system when it comes to how we interconnect like how we interconnect parts of the grid to support each other, so that when one side needs support, the other side can help it. And then also from an energy mix standpoint, right? There's a lot of different sources. I mean, Canada's a great example, right? They're like 80% hydro because of what their natural resources are, right? And that same thought process can be put into a lot of different pockets of geographies around the world. And I think we just really need to focus on that. But then reliability is number one.
Yeah, has to be. That's kind of table stakes from our perspective as well. So Matt Neal, president of Siemens Energy, thanks so much for visiting with us today on Energy Solutions. We're delighted to have you, and appreciate all the work you're doing. We want to partner with you to make sure that we deliver on both of those goals.
Awesome. Thank you so much, Todd. And thanks for having me. It was great. Great conversation.
That was my conversation with Matt Neal, president of North America for Siemens Energy. As demand grows, natural gas generation and the turbines behind it will play a critical role in maintaining reliability. But long lead times are now shaping how quickly that generation can be built. This is a challenge facing all developers, competitive generators, and vertically integrated utilities alike. As Matt shared, the good news is that manufacturers like Siemens Energy are investing to expand capacity and bring new technologies to the market as natural gas-powered generation technology becomes even more efficient and lower emitting. And competitive power generators are taking actions to secure turbines and deliver the reliable, affordable electricity needed to support economic growth. Thanks for listening to the Energy Solutions Podcast. If you found this episode valuable, be sure to subscribe and share it with your colleagues. To learn more about how competitive power generators are helping meet rising electricity demand, visit epsa.org. The music for this episode was produced and recorded by Let Me Hold That Ltd. Until next time, I'm Todd Snitchler.
Energy Solutions is brought to you by the Electric Power Supply Association. EPSA represents America's competitive power suppliers, bringing about 225,000 megawatts of power generation resources to customers throughout the United States. The music in this episode is written, produced, and performed by Let Me Hold That Ltd. Discover the power of competition at www.epsa.org.